Hello guys, welcome again to Math County. This is the second part of the solution of problems and the limits. So if you have not watched the first part of this video, just click on the link up there and then watch that video before continuing with this video for better understanding. Okay, so continuing with the questions. So we can see clearly that for this function here, if we substitute x into the equation, that is f of x, where x is equal to 0, it's going to give us f of 0 equals square root of 2 minus square root of 2 all over 0, which is 0 over 0. And this is obviously indeterminate, right? All right, so what can we do to simplify this function? Okay, so we can easily rationalize this function by multiplying both the numerator and the denominator with the numerator, but changing the sign. So what we can say is square root of 2 minus x minus square root of 2 all over x, right? So we multiply it by square root of 2 minus x plus square root of 2. So we have square root of 2 minus x plus square root of 2. Okay, so I implore you to do the multiplication. So we are going to have square root of 2 minus x squared, right? Minus or plus square root of 2 times square root of 2 minus x, right? Minus square root of 2 times square root of 2 minus x, minus square root of 2 squared over x times 2 minus x. Make sure your square root covers everything, and then square root 2. All right, so if we simplify this, we are going to have 2 minus x. This goes away, right? And then we have minus 2. And then we have x times square root of 2 minus x plus square root of 2. Okay. So to continue, for the numerator, these 2 goes away. So we have minus x over x times square root, 2 minus x square root of 2. So x goes away, we have minus all right, so we have minus 1 over square root of 2 minus x plus square root of 2. Okay, all right, so we take limit as x approaches 0 of this function. And then we have minus 1 over 2 root 2. Okay, so the limit of this function as x approaches 0 is minus 1 over 2 root 2. So let's look at this other question here, which says that true or false, if the limit of a function such that x approaches a is equal to b, then the right hand limit is equal to b, and then the left hand limit is equal to b. This statement is very true. From previous examples, we realize that if the limit of a function is true, then the left hand limit is equal to the right hand limit. So this statement is true, right? All right. So let's look at a few other examples. Okay, so this is a question on continuity of limits. Right? All right. So the question says we should state the value of each quantity if it exists. If it doesn't exist, we should explain why. Okay, so the first one says that we should determine limit of g of t as t approaches 0 from the left. Okay, so that is to say the function plotted here is g of t. So this is 0, right? At this point, we have 0, 0. We have 0, 0, right? So the point 0, right? As the point approaches 0 from the left, we have this curve, okay? So this curve goes down, and then here we have -1, -2. So we can see that as the point approaches 0 from the left, f of x approaches -1. So here for a, which says that limit as t approaches 0 from the left, g of t is equal to -1. Right? Okay, so let's look at limit as g of t as t approaches 0 from the right. Okay, so from the right, 0, again we have our point 0 here. So the curve on the immediate right of the point 0 is this curve, right? Okay, so as we approach 0 from the right, this curve definitely approaches -2. Okay, so from the right we have limit as t approaches 0 from the right, g of t, did I say x here? T, sorry. G of t approaches -2. Okay, great. So how about this question? So it says for C, we are to determine the limit of g of t as t approaches 0. Now, according to the previous example we just did, for the limit of g of t as t approaches 0 to exist, then the left-hand limit and then the right-hand limit should be equal. But we can obviously see that the left-hand limit here is equal to -1, while the right-hand limit here is equal to -2. So if this is equal to L1 and this is equal to L2, then L1 is not equal to L2. Hence, limit as t approaches 0, g of t does not exist. Great. Okay, you can try the rest if you want. You can pause the video and then try them. Okay, but then let's continue. All right, so here we are to find the limit as t approaches 2 from the left. So we have 2 here. Okay, so D, for D. From the left, we have f of x approaching +2. Approaching 2. Okay, great. Now, for f, so sorry, I think I mixed it up a bit. So from the left, we have +2, and then from the right, so we have 2 here, and from the right we have this curve on the immediate right, and then approaching 2 from the positive side, we have 0. So f is equal to 0. Alright, the next question says we should find g, which says we should find what? G of 2. For g of 2, obviously, if we place 2 into the function, it says here that the value is 1. Okay, so g of 2 is 1. Right? Okay, so the last one says we should find the limit as t approaches 4 of g of t. Okay, so this is 4, right? This is 4 right here. So from the left, we have 3. Okay, we have 3. And then from the right again, we have 3. Okay, therefore, limit as t approaches 4 of g of t is equal to 3. Alright, let's look at one more and then we can move on to something else. Alright, so for this is a similar question as the previous one, okay? Again, if you want to try this out, you can pause the video and try it out yourself, okay? But then let's see how this goes. So this one says we should state the following, that we should find the limit of the function a of x as x approaches negative 3. Okay, so we have negative 3 here. Okay, as x approaches negative 3 from the left, you can see that the values keep increasing but never meet negative 3. Okay, so we see that for a we say limit as x approaches negative 3, a of x is equal to positive infinity, because it keeps going up and up and up without bound. Great. And then let's look at it from the right. Again, from the right, as the values approach negative 3, it keeps increasing and goes up without bound. Okay, so right, so it also increases and then the limit approaches positive infinity. So we say that the line, the vertical line, that is the line x equals negative 3, is a vertical asymptote. Okay, we say the line x is equal to negative 3 is a vertical asymptote. Okay, great. Now let's look at the point B, the second question B, right? It says we should find the limits of ax as x approaches 2 from the left. Okay, so from the left, we have the values coming in from the left and moving down. Okay, down without ever meeting positive 2, right? So in that case, we say that limit as x approaches 2 from the left is negative infinity, because it keeps going down in the negative direction. Let's look at the third one. The third one says as x approaches 2 from the right. So from the right, which curve is on the immediate right? It is this curve. Okay, and as we are approaching positive 2 from the right, the values keep going up and up and up without bound. So from the right, we have limit as x approaches 2 from the right equals positive infinity. Right? Okay, so D says we should find the limit as x approaches negative 1. Where is negative 1? Negative 1 is here, right? let's indicate -1. Great. So if this is -1, let's look at what happens on the left hand side when the values approach -1 from the left. As we can see, the values keep reducing and reducing and keeps going without ever meeting -1. So again, the line x equals -1 is also a vertical asymptote. So we say that the limit as x approaches -1, ax is equal to negative infinity. Obviously, if you consider the values from the right again, as it approaches -1, it also approaches -infinity. So our answer here is correct. I hope this video helps you, and I pray you just understand this video. If you have any questions, just type them in the comment section below and I will attend to you. Thank you for watching and meet you again in the next video. Bye bye.